Good. You're good. Okay. Our usual
shoot my sucker. Hello.
our usual meeting location is ruined because there's kids in our classroom. So we are meeting out in the middle of a hallway, which might be a little bit distracting, but that's okay. We're just gonna push on through. There's my lab stuff. Crap. Honestly, it's not that important. If you talk normal, you're fine. Okay. Number one. Okay. Yeah. So I'll share number 3. There's 2 children, a mass 20 kilograms and 30 kilograms, sit balanced on a seesaw with a pivot point located at the center of the seesaw. If the children are separated by a distance of 3 meters, at what distance from the pivot point is the small child sitting in order to maintain the balance? Okay, so we know that it's balanced, that the seesaw is sitting perfectly still, and that there's 3 meters in between them. But the problem is one's 30 kilograms, one's 20 kilograms. So what I did is I added their weights together, which is 50 kgs. And then I found the percentage of each. So for 20 out of 50, it's 0.4, and 30 out of 50, it's 0.6. And so I multiplied the 3 meters by 0.4 and by 0.6. And so I know that the heavier child has to be closer to the axis. So he would be 1.2 meters away, and the 20 kilogram child would be 1.8 meters away. And that's it for me.
Okay, I had 7 through 9. I'll just do number 7 or number 9. So it's the when a father lifts a child. With what force should the upper leg muscle exert to lift a child at a constant speed? So the equation is FQ times 2 centimeters equals the weight of the leg times 20 centimeters plus the weight of the child plus times 38 centimeters. So to find the weight of the child, we do 10 kilograms times gravity, which is 98 newtons, and the weight of the leg is 4 kilograms times gravity is 39.2 newtons. So then we plug that back in. So you go 39.2 times 20 plus 98 times 38, and then you divide it by 2, and you get 2.25 times 10 to the third newtons. So that was that. Okay, in mine, I'll just do the conceptual question. It was number 6, and it says, suppose you pull a nail at a constant rate using a nail puller. As shown in figure 9.23, is the nail puller in equilibrium? What if you pull the nail with some acceleration? Is the nail puller in equilibrium then? In which case is the force applied to the nail puller larger and why? And then I put no, if a nail pulls with acceleration over the nail puller, then there's no equilibrium because there's more force acting on the nail. So that's what I got for that.
Sorry it's a short meeting. This is a terrible place to meet because we are in the middle of the hallway, and you can probably tell there's a lot of people talking behind this. So we just keep it short this week. But yep, glad we actually. This is probably the best way to understand things because we're all in the same kinesiology class, and we actually all just went over torque and stuff, like basically everything we're covering now. So
Nice.
Super helpful.
Yep.
Anyways, see you later.
Nice to meet you. Have a good day. What did you do? I did my test. I'm like super.
Keep it going.
I got sick with fall last week, so I just everything was down.